This naturalrefrigerants.com article is being read by an automated voice. Part 2. SWEP Brazed Plate. Heat Exchangers Turn Data Center, Waste Heat into Energy by Christina Hayes. Published May 5th, 2026. This is an excerpt from an article featured in Atmosphere's Clean Cooling for Data Centers 2025 report, which can be downloaded here. Atmosphere is the publisher of naturalrefrigerants.com. You can read Part 1 here. SWEP's work with data centers began more than a decade ago and was initially focused on free cooling. Around 2020, as data centers became denser and more energy intensive, the company shifted toward liquid cooling, and around 2022 it began seeing increased interest in heat recovery and reuse from data center operators. Since 2021, SWEP has supplied more than 70,000 brazed plate heat exchangers, BPHEs, for data centers globally, with its products widely used in coolant distribution units as well as immersion and free cooling systems. One of our strengths is our global reach, Christer Frenfeldt, Business Development Manager at SWEP, explained. We can support customers in the Americas, Europe, and Asia Pacific. Another key advantage is SWEP's extensive range of BPHEs, which delivers scalability into the megawatt capacity. We always find a good product to fit most applications, he added. Other manufacturers are not able to offer that. For liquid cooling, SWEP is most active in the US, while the majority of its heat recovery work is in Europe, Frenfeldt noted. He estimated that SWEP is currently working on 20 data center projects that involve heat recovery and heat reuse, with several more in development. SWEP's data center business has grown significantly in recent years, driven by rising AI workloads and tightening efficiency and heat reuse regulations, particularly in Europe. The company expects to see strong growth opportunities in the urban centers of Northern Europe, where data centers will offer a valuable heat source for district heating. Another interesting future market is the Middle East, where demand for data centers is on the rise. Growing concerns about water scarcity are driving the adoption of two-phase immersion cooling in the region. While excess heat is unlikely to be reused in the same way as in Europe, low-grade heat can be beneficial for use in water desalination processes, noted Frenfeldt. Heat recovery at the Eco Data Center. Eco Data Center is a high-performance computing and artificial intelligence facility with 80 megawatts of installed IT power capacity located in Falun, Sweden, and owned by real estate company REM. The site operates entirely on renewable electricity, with 75% coming from hydropower and the remaining 25% from wind. Across the facility, a total of 10 BPHEs from SWEP's B220, B320, and B85 ranges have been installed. Some of these units support the data center's free cooling system, which helps the facility reduce its dependence on mechanical cooling, particularly during Sweden's long cool seasons, significantly cutting power consumption. The other SWEP heat exchangers are integrated into the facility's heat recovery system, enabling efficient transfer of waste heat to external users and helping maintain a power usage effectiveness, PUE, of 1.2. The heat recovery system captures low-grade heat from the data center's chiller condensers at 30 to 32 degrees Celsius, 86 to 90 degrees Fahrenheit, and transfers it to a nearby combined heat and power facility operated by the municipal utility company Falu Energy and Vatten. There, the recovered heat contributes to the production of wooden pellets, supplementing the CHP plant's biofuel supply. Roughly 50% of the plant's total process energy is covered by the heat sourced from Eco Data Center. When pellet production pauses, typically outside daytime operating hours, the recovered heat is diverted into Falun's district heating network, supplying local homes and businesses with heating and domestic hot water.